Welcome everyone to an amazing evening live stream here straight from our amazing Exacode headquarters here in Berlin of our nice pet projects. And what you see here is no less than hardware accelerated 3D on this amazing, well, sort of kind of Silicon Motion 3DM Lynx3D. And yeah, of course, this is frame buffer. If you're interested in all this stuff and you are new to this channel, first of all, welcome. And also there are plenty of videos of DOS stuff, low-level stuff on the Verge, S3 Verge, Voodoo, even ISA cards, Trident, Cyrus Logic, and fun stuff like this. Even ET, the very first teasing ET4000W32i. On the ISA bus, we have done this on a real 386 and stuff. And 3D stuff I've done already on the S3 Verge and Voodoo, mostly for the educational fun, well, my fun and your education, because I want to inspire more people to get into low-level programming, not only this fancy JavaScript something, but yeah, we need more amazing operating systems and drivers, in my opinion. And what is more matching to the 28th birthday of the Linux kernel to present people how to write modern and new code, because in my opinion, maybe after 28 years, it's maybe becoming a little bit of too much legacy, vintage stuff. And yeah, as you see here, 3D Lynx, I've only started a couple of days ago. There was maybe only one live stream previously that you find in the previous video. And I expanded a little bit on this, as you can see. Also this time here on this is, by the way, intentionally upside down. This is some Linux frame buffer bug. And also to the Linux birthday, I have the feeling they broke support for booting anything older than a Pentium Pro. This is 5.2.10 Linux kernel running from yesterday. Took me a couple of extra hours to get it booting because they now made the page attribute table PAT or something mandatory. You need to enable export options. So I built like 5 kernels, none of them booted because the complaint needs a x86 CPU. Although that is misleading, this is technically 686, but what it really needed was page attribute table. What is this PAT for? Anyway, this kind of fun. Yeah, so always you want to do something, and getting Linux kernel booted takes nearly as long as actually doing the 3D code. Amazing stuff in 2019. Back to the 3D stuff, you have seen in the previous examples that I've done a couple of things already the last time, and one of them, so in the previous example we have done some shim code because all my other my other low-level stuff, Sound Blaster, 3D, Verge, Voodoo was running on DOS, bare metal, because our long-standing goal is to write an amazing stable microkernel that is not only stable but also amazing to develop with. So what is new in this example, because this OCO transmitter Crusoe does not PXE boot here with this USB attached Ethernet, I did not want to bother plugging USB stuff and whatnot. So I wanted to develop here in Linux, kind of a little bit microkernel setup, doing this from user space, just like X drivers. So I'm running my low-level code stuff here on Linux, mapping here the physical address of the hardware, of the frame buffer and memory mapped I/O registers. And in the previous example, we had a couple of stuff. So in the previous example, I only had like, okay, filling this frame buffer. That is, of course, you can do this with opening dev frame buffer, which of course we do not do for this example. We do this a little bit like X drivers, just that I hope that I get here to more modern codes than X drivers. And on top of, so this is a couple of really, well, actually kind of sort of maybe 8 hours of work. But so the other example, we only had fill working, and now I have also bitBLT. So we draw this and we bitBLT this here, bitBLT also block transfer also working, and then we draw lines also working. And by the way, fun fact, not even the Xorg server apparently, at least not now, has line drawing. I always like when what the hardware can do is also working. Is it even the lines? Maybe, yeah, it's a little bit visible there. Actually, the lines took quite some time, unfortunately, but it was relatively similar to the S3 Trio and Trio. Anyway, now we have lines completely working. Not really sure if the Silicon Motion Xorg driver ever had this. At least right now it doesn't have this because line acceleration was removed anyway. Although the old X acceleration architecture code is in there, there is only bitBLT and fill or something, not lines. So maybe X stuff has never used lines. In case you see there's also, by the way, there lines and here lines, a full circle of all the quadrants. And what you see here is this nice, lovely, colorful, shaded, ground shaded triangle is indeed what the hardware has drawn for us. That is amazing stuff. Took a little bit longer than the lines. The lines took surprisingly long, but that is when you have specification, but stuff is a little bit unclear, and it takes a little bit longer. Actually, I did not even expect to have this triangle done there this week. I thought it's relatively easy, then like nothing really worked. I even locked up. I had to reboot 20 times. If you stall the graphic engines, then often the GPUs don't accept PCI writes or something of this anymore. And then you sometimes have to reboot, so a couple of reboots later. And well, theoretically, I have everything as usual. Maybe you don't find this the most impressive. I can tell you it took 8 hours. And something of that sort. And theoretically, we could do everything now. This is, of course, I'm only happy here, my nice, lovely register printout. And I could, if you're interested, tell you some details of what took so long. Probably another hour or two I could have textures probably working. So everything else is just, in all of my examples, S3 Verge, Voodoo, and here Silicon Motion, of course, these are only the basics. I hope relatively readable. The Lynx code here is, okay, let's use VI. Also, by the way, this is running on the Transmeter Efficient, not Efficient, I sometimes misspeak, Crusoe, of course. I also have Efficient somewhere else. So this is running on, actually also maybe best here, also wrong key, with this screen capture, and also what else? So yeah, this is the latest Linux kernel, which annoyingly, you really wonder why they always cause so many regressions and stuff, even on the x86, with bloody stupid page allocation tables that only Pentium Pro and later have. Anyway, so this Lynx example here, again, right now not yet the most amazing, as much as I criticize this Linux kernel Xorg driver. It can still become even more amazing, by the way, to do. We cannot change the to-do from 3D to only, well, 3D is theoretically working, so set buffer, setup, and texturing, and then of course fog and alpha. But this is only typing all the register stuff here from the spec into this and using it. All the complicated stuff to actually get this hardware to do something is done. This is, in my opinion, 90% of the time, and the rest is only, it's usually, probably, I hope you agree, usually much easier to build on a nice foundation. The foundation is there, and this is only now dedication and time or money. Documented here the memory mapped I/O register regions. Oh, by the way, I also did, fun fact, on top of all the other stuff, lines, bitBLT, I also did the cursor bit, so hardware cursor also works, because why not? Just for our microkernel that eventually will, as quickly as the Xorg people delete code, maybe our microkernel will support more hardware in 5 years than Xorg. Anyway, what is mostly newsworthy or noteworthy is what I already said in the original live stream, that this hardware here, Lynx Silicon Motion, the vendor was so lazy. As far as I know, the only 3D driver exists for the Windows 95 family, maybe it targeting Windows ME or something. So this nice OCO01 was actually shipped with Windows XP, and I probably still have it on here, I guess. And as far as I know, this is of course really set right from vendors, in my opinion, a little bit silly, that they ship a product and they don't even have 3D acceleration. And yes, it's only texturing, and it can even, I think it can do dual texturing, multi-texturing. And of course it's not the most, but I would guess you can probably run Quake 3, I guess. Probably should be possible to run. But in any case, even if it's not the most amazing, I would always prefer if the hardware features are exposed and you can make use of it, play some vintage game or run some light. Actually, fun fact, I even run AutoCAD 14 on there from 20 years ago from my professional AutoCAD training stuff. I layouted our bathroom, so much to fun fact. Totally usable, of course, not using hardware acceleration, but driving some display like this, drawing some 2D lines, no problem. But yeah, this is the irony, right? The vendor was so lazy, they never have done a Windows NT family kind of driver. The driver only did 2D, of course, the bare minimum, some bitBLT, fill, line, copy stuff. And yeah, after the vendor, it's of course hilarious, the unsuccessful one-man distribution guy on YouTube is doing what not even the original vendor had the dedication and motivation to. The triangle actually, okay, it could also do lines, 3D lines, 2D lines. I've done 3D lines similar to the Verge, it could do, but 3D lines a little bit annoying. I'm not really sure if I would want to do this here. Need to think about this. Anyway, the code not too bad, I would say. Of course, well, again, this is the most minimal educational code. Usually, what I usually criticize the constants in other functions like bitBLT. I have here already nice source X, Y and stuff, but yeah, this triangle, in my opinion, this is much more readable than many Xorg drivers and stuff. And even, I said this in the original video, even the Linux frame buffer does not even have bitBLT acceleration. So somehow my bare minimum 2 days of work driver is already, well, of course not feature complete. You would need to sit there, type down all the features and wire them up to some API. But yeah, 3D triangle, how does it work? Just like on the Verge and Voodoo, all of those are really similar. In my opinion, you could actually do some like one first generation 3D stuff and wire this register rights to all the just different registers there. Of course, well, the concept is so similar, the Verge, Voodoo and Silicon Motion Lynx3D, it's like 90% identical, just of course other register offsets and bits and pieces. And yeah, here already nice symbolic constants. Of course, here some other stuff needs some nice symbolic constants. And yeah, this is only, I was randomly had to try around there. Not a big deal. This is X0, Y0 and Z0 and color 0. Not a big deal. But I had to randomly poke around there because, and again, so doing one ground shaded triangle here, just a very few lines of code. And you can do this even more optimized. So normally you would direct memory access this. The hardware can do this. This is of course, for this we would need to pin one memory page there in memory, and the format is not very well documented. However, I have not implemented DMA on either the Voodoo or the Verge. For very high performance you could do this, but so far I'm already happy that this works. And next are of course textures. Yeah, so just as on the Verge and Voodoo, just filling the registers, the Silicon Motion has similar to the Voodoo 2 setup engine. On the Verge and the Voodoo 1, you need to compute all the delta values for the edge walker. Edge walker meaning you have the hardware algorithm here just walking along the edges and filling this span there. And even earlier cards, you had to compute delta values and the hardware would just bare minimum iterate those delta values. The Silicon Motion here already has a setup engine, making this really nicer, just filling in the coordinates. And well, just. The documentation here is really brief. I called this out, but I'm already thankful that we have documentation at all, because they even call this here summary. So all of those registers are actually, well, many of those registers are not even documented. So I had to guess, and well, some guesses are of course easy. X, Y, Z 0 and texture stuff, color, S and T for the texture, and go. The problem with under-documented is that some stuff like go 0, some of the stuff is really unclear also. Actually, yeah, I think this is a color. This is also a little bit, yeah, I'm not really sure. I think this is a normal color and this is a specular highlight color or something of that sort. Also, there are some typos here. This one needs to be a 0. There are also some more typos I found in the meantime. And yeah, also so many of this stuff is a little bit trial and error. This is why did this take 8 hours? So on the other side, on the Voodoo, it took even longer. Although the Voodoo documentation is more complete, it took longer on the Voodoo because the Voodoo is a little bit more of a bitch. And then to show you here, so for example, it was not even clear how to start a command. So this is really, as I said in the earlier video, the 2D documentation, the like mode setting in 2D is 200 pages and 3D is only here a couple of 20 pages or so. And where would this even be right now? Somewhere scrolled. Motions, this is motion compensation. This is DMA. Yeah, so DMA is also a little bit under-documented, so there is some DMA stuff that sounds reasonable, but the format I'm not really sure. So if you want to use direct memory access to BitBeal to transfer a whole block of vertex data, you would need to trial and error the format. It's not really documented, so not really sure how long that would take. Or anyway, this is this kind of stuff. I'm already happy that it works and accelerates something. The last 10% performance for a DMA, don't really need that, though you could certainly do it if you wanted to. There's even, so okay, this was a summary, so maybe this starts with a summary. So some of those registers like yeah, even like set initial value are probably not even documented at all. Only some of those bit fields are documented. By the way, the difference, so you can choose whether you want to use Direct3D compatible or OpenGL compatible. The biggest thing, I think it's mostly the same Direct3D register. So if you change this bit in the setup registers, this is the same address range here. So register 100 upwards is either Direct3D format or OpenGL here, somewhere here. You see this starts at 100 again, so this is the same I/O mapped range. The biggest difference as far as I see, let's see, IEEE S1. Yeah, so one of the differences, not really sure about the precise differences. The main difference I found is that for the Direct3D stuff, you have the color as 8-bit RGB, ARGB here, 8888. And for OpenGA, you have those as floating points here. And that is yeah, what would be a stream without the failing TG3? Usually I take it up and down again because amazing monolithic kernel drivers. Maybe network kernel for microkernel we need to do next. Hope not too much was missing from my Direct3D versus OpenGL. But the biggest thing was where I really had to use some hours of poking around there was how to issue commands, and this is, as I said, quite under-defined here. For example, here are the 3D commands with all the bits, like you want to enable set buffer, never pass, always pass, enable at all, update, and this kind of stuff, again, similar to the Verge and Voodoo, whether to texture or not, and so on. And then here's also a command. Here's also the OpenGL versus Direct3D vertex format selection here. And all quite reasonable stuff. The more I'm surprised, like nobody at Mesa ever has done this, or the vendor for Windows NT. And then here's a command. Maybe this was already the command here. Let's see, 3D draw here, set 1, this bit's 0 to 1. So here, and this is totally unclear what I mean with so many bits can be documented and yet you have so many questions. So normally when you write the command register, either writing on the command register for bit BLT or line drawing in 2D, it issues a command, and here this is unclear, right? And this is where I had to try around. I easily, as you can probably imagine, you lose hours quickly. You think this works and then it doesn't work. So what I found also, and so as far as I know, writing this command doesn't start the command, surprisingly. So if you use the setup engine again is pre-computing this delta values for the edge walker. By the way, do we have audio after restarting OBS? I didn't check actually. Super clever. But yeah, we have audio. So as I found on trial and error and thinking about this and reading here each fine print, here are this go register in vertex. So after each of those vertex data registers, there is, depending on whether you have selected Direct3D or OpenGL, you have either Direct3D is 120, or register 120, 144, 168 hex, or if you have enabled OpenGL, because then all the registers move a little bit due to the RGB being floating point values specifically, then you have this go register at 138, 78 and 1B8. And this is, as they say, this is the same register spread to 3 different locations, and it's connected to the same physical register. And here is also a start active setup, active the setup engine. And of course the English, probably some Chinese co-worker has done this there at Silicon Motion somewhere, active the setup engine. So after a lot of reading and trial and error and testing and comparing and seeing what happens, I figured that this, also by the way, I need to check that my battery is not overcharging. And it is charged, okay, good. Not that the battery explodes here live on YouTube. So I found then with trial and error that you can specify the command and then you write all the vertex data, and then eventually if you're done with this, you trigger this all go. And I think you need to set both bits, and when the setup engine has calculated all the delta values and written this fun fact, they even have documented here the internal edge walker rasterization engine. So as usual, just with the 500 scanners I reverse engineered in 200 years, not 200 years, 20 years, but it certainly feels like 200 years. I realized already talking with some vendors that we work with there at Exact Code for Exact Scan, that sometimes I know the scanners better inside out than some of the vendors. And I have the similar feeling here with the working 2 days, 8 hours or something with this Silicon Motion Lynx3D. I have the feeling I know this hardware really better than those developers. So they have specified here also the internal rendering registers, and they are these here, rendering registers. And those are, you can either write them directly yourself, but they are again a little bit underspecified, so you would have to do some guesswork. Because you see some of the stuff is of course obvious, like Xstart, but similar to the Verge always renders from the bottom to the top. The Voodoo always renders from top to bottom, I think. So here probably this has similar requirements, and without knowing those requirements, because the setup engine will sort and compute the delta values. So even so, this is not documented here. As I said, extremely sparse quick reference, and certainly you understand how happy I am to have here my shaded triangle and probably textured next. So the setup engine takes those values, computes all the deltas and stuff, and then probably I actually output them here. So the register output here should be what the setup engine computed. Let's see. So these are the start, red start, green start, blue start, and yeah, whatever the engine internally does, and then X start, X end here. So internal fixed point or whatever, yeah, signed something. Yeah, so this is internal fixed point format with signed 11-bit significant 12 fraction. And yeah, again, this would take really long, although you could derive this. I think this should be valid from what the setup engine. So what we do, we write here to the, I don't dump here all of them, but X1, so we write, for example, X1 and Go and stuff, and then the setup engine in the internal. I think they at one location they write microcode like Ucode, so I guess this is internally microcoded, maybe. And yeah, really happy. I did not expect to get here some garage shaded triangle this week. Totally happy with this. Totally, yeah, the display is not the most amazing. It's transflexive whatsoever from 2005. But anyway, amazing stuff. Yeah, upside down, need to fix the frame buffer, maybe also another day. Yeah, also another thing, so this was really trial and error. How does it work? This is, as you see, probably yourself mighty under documented. And why do I also do this? You see, this is not like trade secret as it, in my opinion, NVIDIA should just release their shit. This is unacceptable that they don't do this. I would never buy hardware for writing my own amazing microkernel or Linux kernel or BSD something. Can't do this. One more thing, the BLT, of course, this 2D is separated. BitBLT, of course, all of this stuff works, as you have seen. And here are the 2D commands. This is also really strange because here's also 3D operation. So at one point, because nothing really much happened, I even locked the drawing engine, had to reboot a couple of times until in the meantime, I actually figured out how to reset this. I have even implemented code for this because why not? Certainly want to have the most amazing microkernel eventually, supporting the Silicon Motion Lynx3D with hardware isolated 3D. Where's my test program? Is somewhere here. And reset. So this code is not amazing, but probably, I think, in my opinion, for 8 hours of random trial and error, it's relatively okay-ish. So setup engine, if the engine is busy, you can reset it by writing there some 2D, 3D abort bits and clearing them. That appears that avoided a couple of reboots for me. Those apparently work. So if the drawing engine keeps busy for a prolonged time, then your graphic driver can say, you know what, you will not finish this triangle because we messed up all the values. Smash it here with some sledgehammer and reset the engine. That apparently worked. And if you don't do this, if you write more registers after this, if the engine is busy, then you lock up your whole system. I think the PCI bus doesn't accept writes and doesn't acknowledge this, and then the whole thing locks up. Anyway, apparently normal with PCI programming, so I heard or have seen in my experience. So yeah, no idea what this is doing, because there you see lack of documentation. If this is a little bit under documented, then you try this bit and that bit, and yeah, texturing should be relatively okayish, maybe another 8 hours for texturing. I could be lucky. Basically, I know all the registers, so this is only texture base address or something. Well, only and only here, texture base here. So texturing, in my opinion, is just writing here. So copying the texture, certainly in video memory there, like the cursor or stuff, and then writing the base address here. Of course, the texture needs to be aligned, similar to the Voodoo and stuff. So the texture here needs to be 16-byte aligned, 128-bit aligned, as you can see here. So load the texture, load as just memcopy it in there, specify the base address, set up all the SNT, and then the only problem is the scaling, the usual problem. Not really sure which kind of scaling it applies. Also, by the way, MIP does it do MIP mapping? Maybe it does enable MIP map texture. Yeah, this MIP map, this is a problem. This will be some trial and error texture size, because this is not really documented here. So level of detail, so this kind of stuff, lot bias. Again, this will take a couple of 8 hours each to trying all the stuff there and figuring out how the MIP mapping work. But yeah, these are small details. I've already done here what nobody open source and nobody on Windows NT has ever done on this hardware before, I guess. Totally happy, amazing treat here. Fun stuff, as I said, more amazing than Tetris or Sudoku. I hope you find it as amazing as I do. Let's see, what do we have in the comments. When you reverse engineer something, you normally find all the patches. What do you mean? It's like trying to get a new code base to compile. You are starting with No assumptions. What do you mean with when you reverse engineer something you normally find all... gotchas, not patches, gotchas. It's like trying to find out in a code base to compile your starting here. So probably Dave means also what I said, getting the basic stuff, so figuring out, like for example, how to even start the command here to draw this. That probably took the longest, and now that I know how to engage a command, the rest should be relatively simpler. Also moves this here the wrong way. Too many windows. Where did I even wanted to move it? To move it here. Yeah. So the other stuff. The problem is, I really wish more people would actually share, like, and subscribe and stuff. Although I'm actually surprised that so many people were interested in this and agreed that it would be amazing, and to have this to work and test CC. So I can also enable the hardware cursor. I have already code here, not making this stuff up. Took a couple of 30 minutes also to do that. Let's do here true, some address here, some 4 megabyte address. Load there our standard cursor and compiling and running this here new, and then we will get, which do I even show this? Probably, hopefully. Yeah, compiling takes a while on this gigahertz crucial here, code morphing this here, the compiler, and then our program, especially as it's a little bit lightweight C++, so without that. Now we have a cursor there, as you probably should be able to see. Amazing stuff that I can't move right now. On DOS I have mouse support. I don't have here any mouse glue, but there's a hardware cursor. And yeah, next, certainly I'm actually really surprised that other people were immediately interested in also even specifically the Silicon Motion, even chiming in there that it said that the driver... Did I now kill something? Maybe. Always here for YouTube, that the drivers are getting... I know, didn't kill it, just moved it somewhere. Where did I move it now? Anyway, yeah, reoccurring... here's Google Chrome. There it is. Minimized it or whatever. Cool, more people joining in. Yeah, I'm at least totally happy, more than I expected this week. And creating here also for the project, welcome everyone. For my project, why do you ask, do I do this well? I have here NVIDIA stuff for the PS3. And when do you ask, why did I do this well? I really like this. I hope this machine, I could of course be unlucky and it overheats another month. But though because it's a little bit of a kind of museum piece for me, this is why I wouldn't really collect some garbage and for this kind of museum pieces. It is the only Silicon Motion Lynx3D I have. A little bit excessive work, but it's also for your education and my fun here. So otherwise, just for one machine, yeah. But again, the project is also long-term microkernel and documenting this, so I hope you find this code relatively readable for other people to get an understanding and kind of historical understanding how this is programmed and developed. This is why I create this repository of kind of Rosetta code here, and you are able to drop it easier within your skills, reading someone's scare documentation specification. Also, hi, yeah, welcome everyone. And yeah, of course, we will continue. So you might ask, the thing is, I will not most likely, as much as some people probably would want to see me doing a full Mesa driver, I will probably not do this for the reason that I don't like this vintage C Coast base, although you can certainly donate and pay me for that. But I have here other goals. Again, we could certainly do this, but the Mesa people are a little bit, yeah, delete all the fixed function, Verge and whatever, even Matrox code. And yeah, over the next years, not really sure. I want to a little bit varying content, so next is certainly PS3. But eventually I also want to do the same for the Riva TNT. I have one from my brother from Vintage, and RTE, Rage or so, and Matrox, just to have a collection of minimally working. And this is why I will probably not spend a week or 40 hours to perfecting this to really run Quake. Although I will for sure set up texturing and other fun stuff. But you can certainly contribute, right? The code is there. SVN can actually go there here. And SVN kernel. Because I think it's more educational fun to get it working at all than documenting here and wiring up all the bits and format pieces. However, I will most likely develop a unified API that you can use this code, like some readable code, example code, and develop demos and games. And we will probably get there. I have already some spinning cubes for the Verge and Voodoo. I will probably next get the cubes and set buffer, and we also need to fill and get working set buffer, and then texturing, and then the spinning cubes. And I will most likely do some demo, a little bit of game, some space flying, X-Wing versus TIE Fighter or something, another winter day, and documenting how all this works. And but the reason is for not going the Mesa route, for Mesa to do this really the modern way. This is also what I criticize with the Linux kernel. You have libdrm, well, you had frame buffer, then DRI, direct rendering interface. Nowadays kernel mode settings, so theoretically the Linux kernel, people want to get rid of the frame buffer that they just fixed because it was broken, it's still upside down, but at least it's doing something. And so they want to get rid of frame buffer, they want this mode setting in kernel, and then libdri and libdri for the working with the directly mapped buffers, and then Mesa and Xorg. And in my opinion, this architecture is not amazing. I've worked with this for 20 years. I'm doing this unsuccessful one-man distribution T2 for 20 years, previously known as Rock Linux. And after 20 years of regressions here, you see even Linux kernel 20 years later didn't even boot. I had to mess around. I had to literally 5 times build a Linux kernel until it worked. It's also a little bit ridiculous, especially it's hilarious. So you build a kernel for supporting 486, it doesn't boot on a 486. It's hilarious, unless you enable expert options and disable config PAT or page attribute table or something. Not cool. And this is why after 20 years I rather want to innovate to microkernel, and this is why I'm preparing here educational examples for 3D and other microkernel fun stuff. So next up is also virtualization stuff. Virt.io, our own virtualization glue running in KVM, and certainly easier to follow. And of course we are here a little YouTube channel and doing this for fun and stuff. So a full-blown microkernel takes a year or two, but until then we will have nice graphical peaks here, and we have other fun stuff to come, right? So we have the Sony Vario P that you've seen in previous videos. We have Power VR to do, and I have the similar Power VR Kuro graphic there, AGP card, where we already hot air soldered a DVI connector, also there in the videos below, and then PS3, SG Octane, and as I said, Matrox and other fun stuff. And certainly amazing, cool stuff, I hope. And I hope to see you soon for all of this fun stuff. And I hope, I'm actually kind of surprised the previous videos was as well received with my esoteric, exceptional hardware stuff here that few people have. But again, it even was included in the MIPS Limo stuff with this Longson MIPS CPU netbook that even Eric as Richard Stallman endorsed, this totally open MIPS Longson netbook stuff. And it was used in some IBM ThinkPad that was mostly an Asian SKU. So it's not like the chip wasn't used, it was used. Fun fact, they still even have, Silicon Motion is still around, they mostly do SSD controllers nowadays and other fun stuff. They still have an embedded GPU, and successor of this, even with video acceleration, something, whatever that was, H.264 maybe or something of that sort. But they removed this 3D function. I really wonder why this small edge walking rasterization engine that they removed this, a little bit strange. can't take up so much silicon. I don't know, but maybe they just don't have human resources for this. Nowadays, of course, this is only fixed function OpenGL and Direct3D. Nowadays, you want to have all the programmable vertex shaders and fun stuff like that. But we will be getting there, so not sure where we are getting there. Of course, right now, this is unsuccessful one-man example code here that is a little bit funny. I hope it is at least readable, and I also hope to inspire other people to even work on Mesa. Of course, nowadays Mesa is huge and stuff. And yeah, this code is only some hundreds of lines to get triangles out of a Verge, Voodoo, and now Silicon Motion Lynx3D. I hope this is more readable than Mesa, especially on Mesa kernel user space and libraries in between. You need to work on so many pieces. And in my microkernel, eventually I would want to have like one graphics server where this is running, and so you have it. I showed this here. It's so much nicer to develop with this. You just hear G++, you program. This is how I would prefer to develop drivers, and not this module loading and overwriting all your kernel memory stuff. Because as I said previously, in a monolithic kernel like the Linux kernel, if you do this in kernel, I for sure would have had to reboot 100 times, just because if something crashes, then you override some kernel memory, and here of course some user space process. Even if you memory map your frame buffer and your registers, as long as you don't DMA, you cannot really crash the rest of your kernel. Well, the most stuff you do is lock up the engine and stall the PCI bus, but yeah, just your kernel driver can also do this. In my opinion, the trust level, if you trust your driver, either your driver works and it is bug free, and then it is nicer to develop and more isolated, and maybe with modern PCIe you can't even crash and hang your PCIe bus as easily, maybe, not sure. But that is a hardware thing. I wish the hardware would be developed in a way that it can't store the PCI bus, but that's something for hardware development, not for monolithic versus microkernel. And yeah, in any case, I would, after 28 years of Linux kernel monolithic goodness, I have a little bit the wish to move on and have a little bit more modern setup, but leave all the monolithic versus microkernel flame war down there. And also what you think about my efforts here. With time totally wasted or efforts well spent. Looking forward to hear from you. And yeah, we have here a fully licensed box copy of Quake 3 for Quake 3 Arena for Linux, so we certainly will run this as well soon on PowerVR, Kuro and other fun stuff, and certainly get the Sony Vaio out. I really wonder, yeah, as I said, it's totally amazing that we reached 3,500 subscribers with this esoteric hardware tinkering content here. For tomorrow, by the way, I have a totally amazing episode to come, already recorded, waiting to be edited. And yeah, I really wonder how long it would take to reverse engineer the PowerVR. As I said, I not only have the first iPhones that have PowerVR, but also the Sony Vaio coming up next, and Kuro. And I said this in the previous video already, where I soldered on the Kuro DVI transmitter and mentioned this on the Sony Vaio P. Probably I only got the Kuro 2 with PowerVR graphics already a decade ago for my company for €5 or so on eBay, just for the possibility to have an open PowerVR Linux embedded project. Just for that case, I got this card just to have a second next to an embedded board, to have some second hardware to maybe have this binary only driver for reverse engineering. Of course, I mentioned it earlier, this project didn't happen, as so often with embedded projects. But yeah, that's why I have it, and why we could certainly finally use it for something. Let's see, 30 frames. So yeah, they seem to be dragging their feet on that, hardware vendors. Be nice though. And yeah, as usual, just when people tune in, we have here the most people tuning in with a YouTube notification. Theoretically, now I will probably edit the video later today. For texturing, it is, by the way, not so much needed triangle here. If you wanted to do texturing, which did I even open here? Is it the right file? No, it's not the right file. So to enable texturing, you go here to triangle and you just enable here a couple of more bits. So this would be in the command register here somewhere. Well, first I would suggest not to do this with set buffering. Set buffering is here also, no set buffering, no texture. So enable texturing is just setting here some texturing bit, loading here some texturing base, address wherever that was. Also, I need next make this here nice symbolic constants. Probably, by the way, I can try if this still compiles. So this makes this builds DOS examples, and of course they do not build redefinition of something, whatever. Maybe I broke something. I think I can even commit, so because right now this test program for the Lynx is not committed, I think I can simply make this here Lynx3D CXX, for example, because this would not build our make file, only builds the CC files. So this way I could actually add here the Lynx3D example without having it compile by default. And then it's version 2, also for myself, because it's a little bit risky to do all the code. Yeah, also I still have quite some code to do. By the way, because I did not really foresee here, welcome Andreas, it's hard to get notifications for, it's hard to be nice or what? It's hard to get notifications for this for some reason. Interesting. You need, however, to click, there is on the subscription, there is the bell you can click 2 times. Many people don't realize this. So if you click it once, then you only see it in your subscription feed, and you also need to click the bell icon there on the channel if you want to get more instantaneous live notifications. Empty chair for 30 minutes to start the show, then yeah, something of that sort. To structure this, so of course this only started as DOS vintage demos. In the meantime, it's getting a little bit out of hand. However, I have here libc for tiny one-man libc bare minimum DOS stuff that we could also reuse for microkernel stuff. And the directory layout I will probably create similar to the Linux kernel and make it so that most of the stuff is freestanding in the header. So for example, you can, if you want to create a demo for DOS or your microkernel, then you can just use one header. I will probably try to make all the headers so that you can include them without any other dependencies, like this header only libraries. We are not yet there. However, I already moved some S3 code and S3 Verge code already out of there. And the Lynx code I started as a header. So all the definitions will be in one header that you could probably include without conflicts and stuff, only using normal U and whatever types. And then I will probably make it so, did I already? I will probably have a similar layout to the Linux kernel, like architecture and drivers. However, yeah, probably drivers. And I will probably make it so that drivers, like simple drivers like the S3 or S3 Verge, only get one file, and only if it gets more complex for more complex drivers, then I will create the directory. So this will look like mkdir drivers like GPU or something, and then there will be Voodoo header, and like most of the stuff will be in headers, like a Rosetta code like of Encyclopedia here, for people to reuse. And also bus, I think I created bus already. Yeah, bus has already PCI, just some direct register poking PCI stuff that I already use on the Voodoo example. And by the way, I can delete the log stuff here that we are done with. And yeah, I will certainly create some helpers for registers. So because I'm not the most impressed with the Xorg drivers, I said this already the other live stream. This is why I will probably, I'm not the most motivated, because the X people are not really interested in like 2D acceleration anymore. Like they removed EXA, the previous 2D acceleration architecture. So I will most likely, after 20 years of doing open source, I will most likely try to create completely new stuff from scratch, to be a little bit more modern, like really not overdoing it, like not supporting all features, but small, minimal, keep it stupid simple, like the bare minimums that you want to have, like mode setting, lines, fill, bit BLT, and 3D triangle stuff. And so microkernels bootable? No, I've not started. Well, a couple of years ago I started some microkernel stuff that I will not open source as it is like this, but right now we are doing hardware stuff. I do have the bell, but doesn't show up until 30 minutes later. Interesting. The microkernel is not bootable. Right now we are drafting various acceleration stuff, like 3D acceleration for the Lynx3D and Voodoo and Verge. Fun fact, we also have the amazing rendition Verity, so probably I will also try to replicate this for the rendition Verity, the first fully flexible RISC MIPS like programmable 2D accelerator. There are 3D accelerator that we also had videos. I already played Quake with it, of the cards that I didn't even knew existed. Fun fact, this is so old. This is at like Mercury Projects Archives X3, so old it is. Anyway, I criticized this code. Yeah, actually this is not too bad, but by the way, I saw here, so I reset. This is by the way funny. Here's some code review. This is hilarious. Is MSOC here? Then like I don't really know what this is. Some like new mobile SOC. I don't know, something. Otherwise, do this, and this is this reset bit that I also do actually. And then, if not MSOC, then also clear this reset bit again. Like seriously, this is completely alien. Of course, this line should not be there. Maybe fun fact, I just for some more awareness, maybe I actually clean this up, because this code line should just be in there. And then it's hilarious. I have no idea who. This must be some copy and paste. I actually found another typo in here and some other. But anyway. So yeah, but most here are magic values. Many Xorg drivers have magic values. Not the greatest fan of that. I said this in a previous video. So what is missing to a full graphics server? For a full graphics server, a little bit of housekeeping is missing, like housekeeping the texture format. So right now it doesn't hurt, but it's not the greatest performance. So in the blit, right now in the blit function, I set everything in the block transfer. I set everything I need, and theoretically you could optimize this. And actually when I continue this and maybe I make a full-blown 2D 3D graphics server stuff, just because we can, over the next course of the years and months and years and winters and stuff, and maybe it would be amazing, in my opinion, all the regular old-fashioned register bit BLT IO memory map banging hardware stuff, it would actually be cool to have some automatic shadow register map. Actually many drivers do this, like having a state tracking cache shadowing those hardware registers and like only writing the hardware where necessary. And even sound drivers do this. So even like other sound drivers have this kind of stuff sometimes, because even maybe for the RME Digi aided cards that we also already did programming here live on YouTube, and because sometimes even on the aided card you can't read the registers back. So some registers, some command registers on the RME aided card Digi32 you can only write but never read, and similar stuff. So I'm actually surprised that you would make this in a like real sophisticated, amazing architecture, like modern software architecture. You would make this one register shadow class thing and reuse it everywhere. Somehow that's not happening in either the Linux kernel or Xorg. Anyway, this is why, yeah, not really the most motivated, especially, yeah, this code is also too complex and C and stuff, and yeah, maybe it's time to start a new project, because why not? And yeah, empty chair, yeah, so something of that sort. Amazing stuff. I'm totally happy. I hope you hear that. I'm totally thrilled that I have this running. Let's move this over, and yeah, it's not much missing, but I need to go home. So we could have spinning triangles and stuff. Spinning this would be as easy as having a timer. On DOS, of course, we have a timer interrupt, so for Linux I would need to create some select-based kind of timer glue there. Then we could spin it, and then, of course, that was exceptionally not TG3, that was a forced reconnect DOCSIS cable shit. Thank you very much, cable, Vodafone, cable, Germany. Crap, you can't make this stuff up. Are we even 0 drop frames? Yeah, this is really set that it's like this, either TG3 or DOCSIS fail. And yeah, I hope you learned something. Don't forget to share, like, and subscribe. This is also Patreon, because all this stuff takes enormous amounts of time, and somehow my concept does not yet work the most amazing to finance this with YouTube, as you can imagine, a little bit niche stuff. Maybe we need to get more to product reviews, but also Patreon supporters amazing, also for SG Octane and PS3. And graphic server stuff, of course, I could program it so well. Soon we have this running bare metal on DOS, bare metal in Linux, like kind of microkernel-ish, direct, like an old-fashioned Xorg driver. Again, not even the greatest fan of having everything monolithic in the Linux kernel, a little bit, actually, in my opinion, the old-fashioned Xorg drivers were not too bad, but whatever. So yeah, you could run, if we create a modern microkernel thing here, oops, then you could, of course, make it so to run it on DOS, microkernel, and Linux, wherever. Thanks for watching. I need to get out of here, and hope to see you soon for all the next amazing tinkering stuff to come.